Hello everyone, welcome to CHEM CREW. My name is Devam, student of Chemistry Department of Mathabhanga College. Today I am going to discuss the topic Frontier Molecular Orbital Methodology of Analyzing Electrocyclic Reactions. Let's get started. So first of all, we should know what is electrocyclic reaction. Electrocyclic reaction is a class of pericyclic reactions where concerted ring closing of conjugated polyenes takes place to form a cycloalkene, or the ring of a cycloalkene opens to form a conjugated polyene. Here are some reactions of ring closing and ring opening. The first reaction is from hexatriene to cyclohexene, and the second one is butadiene to cyclobutene. Now there are three approaches of analyzing electrocyclic reactions as well as pericyclic reactions. The first one is conservation of orbital symmetry or correlation diagram. The second method is FMO or frontier molecular orbital method, which I am going to discuss today. And the third approach is the aromatic transition state concept. Now in FMO methodology, we consider there are frontier molecular orbitals. The frontier molecular orbitals of a compound are at the frontier of the electron occupation, the highest energy occupied and the lower energy occupied. HOMO, which is the highest occupied molecular orbital, and LUMO, or lowest unoccupied molecular orbital. The analysis is based on the interaction of HOMO and LUMO. By frontier molecular orbital methodology, we get to know about the allowness of the reaction photochemically or thermally. In frontier molecular orbital interaction or the HOMO-LUMO interaction leads to bonding orbital, then the reaction is allowed, and if it does not, then it is not allowed. So today we are doing frontier molecular orbital methodology of analyzing of electrocyclic reactions of foreign electron system. Let's consider electrocyclic reaction of butadiene undergoing a ring closing reaction to the cyclobutene. Now there are 4 pi electrons. So the molecular orbital configuration of butadiene is as follows in this image. There are 0 nodes in Psi1, 1 node in Psi2, 2 nodes in Psi3, and 3 nodes in Psi4. And in ground state, Psi2 is HOMO, and in excited state, Psi3 is HOMO. So if we consider the thermal process, then we have to start from ground state. So Psi2 is our HOMO, or the highest occupied molecular orbital. As we can see here, if the C1 carbon and C4 carbon rotates in the same direction, therefore conrotation occurs, then it forms a bonding orbital. And if the C1 carbon and C4 carbon rotates in opposite directions, it forms an antibonding orbital. Now as we know, the energy of the bonding transition state pathway is lower than the antibonding transition state pathway. So the bonding transition state pathway is favorable if we want to get our product cyclobutene. The process is an allowed process only under thermal condition, as we are considering the ground state molecular orbital of the butadiene. According to the frontier molecular orbital methodology, under thermal condition, it is evident that butadiene can undergo condensatory process, and such a process will lead to a bonding type of interaction. So we can say a foreign electron system in general under thermal condition will undergo a condensatory process of ring closing as well as ring opening, and under thermal condition this rotatory process for a foreign electron system is forbidden. Now as we have seen before, in ground state there are 2 electrons in Psi1 and 2 electrons in Psi2. But in photochemical reaction, we need to consider the excited state of electron configuration of butadiene. We see 2 electrons in Psi1, 1 in Psi2 and 1 in Psi3 in the excited state. So the Psi3 is the HOMO, or the highest occupied molecular orbital in butadiene here. Now at first we consider the disrotation, which leads to the bonding type of interaction in transition state, and if we consider the condensatory process, there will be an antibonding type of interaction in transition state. Here, this rotatory process has more favorable transition state compared to the condensatory process. So, the condensatory process is a disallowed process for a foreign electron system. So we come to the conclusion, based on the frontier molecular orbital theory, for a foreign electron system, it is a coordinatory process which is thermally allowed, photochemically forbidden, and it is a dissociatory process which is photochemically allowed and thermally forbidden. Thank you for watching.